So look, in previously we have done Leibniz theorem. Now today we'll complete what? Application of the Leibniz theorem. So how we'll apply Leibniz theorem in your problems? Clear? So look over. So first is that, first again I am recalling the Leibniz theorem. So we know that we will apply Leibniz theorem when we have to find out the nth derivatives of what? Nth derivatives of the product of the two functions. Clear? So the main part is here u into v. But now look over, in product function in first order and the second order, it is very easy that you can select u and the v any. You can take the first part as a u and the second part as a v. But here very important, while you are finding the nth order derivatives, you cannot directly randomly select u and v. Am I clear? So there is a some part like you have done in integration, that the by parts of integration I let rule. Similarly here also you have to choose. Here remember that we know that two functions, the u and vn is this one. Clear? So you know very well. So again I am writing the first formula. Clear? So what is a u v n formula? So it is Leibniz theorem says u n v plus nc1 u n minus 1 v1 plus nc2 u n minus 2 v2 plus dot dot dot. You can write ncr in middle value u n minus r vr, at last you can write what? u vm vn. This is the formula of the Leibniz theorem. Clear? So now whenever you are going to find out the nth derivatives of any product of the two functions, so you have to choose v, you have to choose v which will differentiate fast and gives you 0. For example, if we see, if we differentiate x square, it become what? 2x one times. If I differentiate one more time, it become 2. If I differentiate one more time, it becomes 0. But sin x will become continue. You yes or no? Sin x. Then if we differentiate one more times, what will it gives you? Cos 2x into 2. Again it will gives you another value. It goes on. It goes on. For example, for that's why you have to choose v, which will, so you have to assume this as a v and this as a u. Am I clear now? Clear? So this is very important. So now before that you must know how to find out the nth derivatives of some functions as well. Clear? For example, if we know y is equals to e to the power of x, now finding nth order derivatives, you know that we'll use second principle of mathematical induction. This is the first principle. Proving part we'll use. What is the second principle of mathematical induction? Second principle of mathematical induction is the, by seeing the series you are writing the formula. Principle of mathematical induction. Okay. For example, I will give you the example. So y equals to e to the power of x. So what is y1? You have to find out. Suppose yn, for example. Remember that this I'm not solving the Leibniz theorem. Okay, I'm solving simple y equals to e to x is one function. You are finding nth order derivatives, because in class 12 we have done only y1 and y2 only. So but what if it will give you y100? So you have to use the induction. So first every time differentiate at least 3 times. So you will get e to the power of x. Applying chain rule, you are getting a. If I differentiate one more time, since a is a constant term, again e to the power of x into a, so it gives you a square. Yes or no? So what is a y3? So y3 is a cube then e to the power. So if you see this one, second principle of induction say that you have to see the series. So what pattern it follows? So if you see it is 1, then it is 1a. If it is 2, then it is 2a to x. So by seeing this one, so we can say that yn is what? A to the power of n e to the power of x. Am I clear up to here? Clear this one? So this is how we'll find out the nth order derivative. So listen carefully, okay? Then what if suppose y is equals to suppose sin ax? So listen carefully. Remember that after derivatives, what is the ddx of sin x? It is cos ax into then a, applying chain rule. But listen carefully, after derivatives you have to convert into same sign format. So can we write this as a? Clear? So then can we write this as a what? Cos as a sine. Can we write pi by 2 plus theta? It is sine theta only, cos theta only. Yes or no? Why I am doing in this way? Because after derivatives, because you have to see the series, you have to see the pattern. So that's why you have to always convert into this. I'm not differentiating. I'm just writing cos theta as a sin pi by 2 plus theta, because we know that sin pi by 2 plus theta is what? Cos theta. It is in first quadrant. Sign is positive. This is very important. And it derivatives. Again, if I differentiate y2, what becomes? A is a constant term. Sin pi by 2 theta. Sin theta is dx of sin x is cos x. Again, applying chain rule, you are getting a. So you are getting a square. Again, this become cos. So again, what I will do? I'll again convert it to sin. So sin pi by 2 plus, now theta is this one. So pi by 2 x. Any doubt? So that means you are getting a square sine. Can we write this as a 2 pi by 2 plus ax? Yes or no? Pi by 2 plus pi by 2. So you see the series. When it is 1, it is a1 sine 1 pi by 2 plus ax. When it is 2, it is 2. If it's differentiate one more times, it becomes 3, it becomes a3. So what is a yn of? Then it is a to the n sine n pi by 2 plus ax. Any doubt? This is how we'll find out the n, because we need this one. Because un we need. Clear? So look over. So now we are proceeding. So you know how to differentiate, and you also know which function you have to choose. We have to choose which function, which will differentiate fastly. So if we see this one, so e to the ax, because we know that e to the power ax will not give you 0. If we differentiate any times, it becomes e to the ax only. But x cube is differentiate. So you have to assume this as a v, this as a u. Okay. So look over. So you have to find out the nth order. So u as a e to the power of ax and v as a x cube. So here you need a un. So what is a u1? So u1 is e to the power of ax into a. So what is a u2? u2 is e to the power of what? E to the power of ax into a square. So similarly u3, you have to write down a cube e to the power of ax. Hence you can say that un is a to the power of n e to the power of ax. Any doubt? Clear? But if you see here, v1 is what? 3x square. What is a v2? v2 is a 6x. What is a v3? v3 is a 6. After that, v4 will become 0. So that means you don't have to find out v5, v6 and v7. Clear? Up to here, in doubt? So in this way, first you have to find v and find u and differentiate. Here in u, you need un. Why? Because our formula starts from un, v1, so on. That's the reason. Clear? Any doubt? Clear? So I am keeping this over here. Just wait. Okay, look over. So this you have to find. Clear? So look over. Now I'll write this one. So look over. So now I'll write differentiating n times using what? Using Leibniz theorem. You have to mention this one. We get. Listen carefully. This is a yn. Yes or no? Clear? So e to the power of ax. This is u. This is v. So clear? So what is the formula? E to the ax. That means you have to write down what? un. So un is what? An. Am I clear? An e to the power of ax. Then v. I'm writing here formula. Okay. un v plus nc1 un minus 1 v1 plus nc2 un minus 2 v2, so on. I'm not using this formula. Am I clear? So un value I'm putting a to the n e to the x. So what is v? V is x cube only. Plus what is the next part? Next part is here nc1. So un minus 1. So if it is n minus 1, so it will be a to the power of n minus 1 e to the power of ax. So what is a v1? So v1 is here 3x square. Next is here nc2 a to the power of what? N minus 2 e to the power of x. What is v2? It is 6x. Plus next is here nc3 a to the power n minus 3 e to the power of ax. It is 6. After that you don't have to do, because it becomes 0. So here you have to stop, and now you have to simplify this one. So if you see, each and every terms containing e to the power of x, so you can take e to ax as a common, so you are getting a to the power of n x cube plus nc1 is n, a to the power of n minus 1 3x square. nc2, I hope you know how to solve this one, n, and then you have to subtract one more times divided by 2. Am I clear? A to the power of n minus 2, then 6x. Last is nc3, so you can write n minus 1, then n minus 2 divided by 3 into 2 into 6. So this is your final answer. So this is the nth derivatives of this one. Am I clear? So you can cancel this. If you have any common part, you can cancel, like this 2 into 3, cancel it, this 6 and 6 cancel it, leave as it is. This is the nth derivatives of this function. But before that, you must know how to find out the nth derivatives of this e to the ax sine x to the power of n, that one also. Clear? Any doubt this one? So can you do next? So here x cube and sine 2x. So definitely we know very well this will differentiate fast, and this will, you have to assume this as a v and this as a u. Clear? So that means u as a what? Sine 2x. Clear? U as a sine 2x. So you have to write down. Okay. Look. Clear? So you have to write down u as a sine 2x. So you need a un. So here u is equal to sine 2x. So differentiate this. So what is a u1? So u1 is cos 2x into 2. But you have to convert into you have to convert to sine, because when you differentiate, if it changes in successive derivatives, you have to again change to the main given part only. So we have to write down 2. This can be written as a sine pi by 2 plus theta. Sine pi by 2 plus 2x. Am I clear? So what is a u2 then? It is a 2 sine derivatives is cos again pi by 2 plus 2x again into 2, applying chain, because pi by 2 derivatives is 0, 2x derivatives is 2. So it is 2 square. Again you have to convert cos to n, sine to cos to sine as a sine pi by 2 plus theta, because this is now theta. So that means 2 square sine 2 pi by 2 plus 2x. So you see that when you have a 2, 1, it is 2 to the power of 1, 2 then. So we can say that what is un? Un is 2 to the power of n sine n pi by 2 plus 2x. Any doubt? So what is v? V is, you know that, here you don't have to solve only. V, we know that. V1 is what? What is V? V is your x cube. We have done that in the previous question. V1 is your 3x square. V2 is your 6x. And V3 is your 6. V4 after that, all values is 0. But this part you have to do in pair only, okay? So that you can see in one board only. That's why I'm writing over here. Clear? So here what we write? Differentiating with differentiating n times. Clear? With respect to x using Leibniz theorem. So yn. Clear? Yn. So yn. So what you have to differentiate again? Same. So this is your unv. So un is what? 2 to the power of n sine n pi by 2 plus 2x, and v is your x cube, plus 2 to the power of n minus 1 sine n minus 1 pi by 2. Clear? Plus 2x, and when you differentiate x cube, it become, sorry, nc1 is also there. nc1. Clear? When you differentiate 3x is x cube, it is 3x cube. Plus next is your nc2, 2 to the power of n minus 2 sine what? Sine n minus 2 pi by 2 plus 2x. Again we'll differentiate this. Am I clear? So when I differentiate this, it become 6x plus nc3, 2 to the power of n minus 3 sine n minus 3 pi by 2 plus 2x into, when I differentiate 6x, it becomes 6. After that, you don't have to solve. So this is your final answer. You don't have to simplify, only leave it, because you will not get the answer. Sin n minus, because you don't know the n minus 2. What is n minus 2? You don't know whether it is even or odd. You cannot find out the quadrant. So leave as it is. This is your final answer. Any doubt? So that means whenever the product of two direct function is given, so how to differentiate, that is important. So for that, you must know how to differentiate sine, cos, x to the power of n, e to the power of x. There is many functions. I hope you have done that one. Clear? So listen carefully. Now differential equation. Then after that, we'll do the proving part. Clear? Now two more questions. So this type of equation, if this is a differential equation is given, this differential equation is given, now you have to differentiate n times. If you know this, and then the next part, last part is the main part, how to prove this type of equation. Clear? Especially 5 mark question will come this type of question. Clear? So first we'll know how to differentiate the differential equation, then we'll come to the main questions. Clear? So this is the equation is given, which is a second order derivative. You have to differentiate how many times? N times directly. So now look, why we have to use the Leibniz theorem here? Because x square is one function, y2 is another function, because we know that y2 is also a function, x and y is a function. So look over. So differentiating n times with respect to x using Leibniz theorem. So definitely you know very well which will differentiate fast, x square. Clear? So listen carefully. This is u dear and this is v. So when I differentiate n times, isn't it? It become like this, y n plus 2, because it is already 2 times differentiated. So if we differentiate n times, so it become n plus 2 v x square plus nc1 y what? Y is this n plus n minus 1 plus 2. Can we write n plus 1? Any doubt? Simple logic. You know very well. The suffix of the u will slowly decrease by 1, 1, 1. Un, then it is what? Un minus 1, then it is un minus 2. But the suffix of the v will increase. So if it is n plus 2, next is n plus 1. What we if we differentiate x square, it become 2x. Any doubt? So next is what? nc2 y power 1 less suffix, that is n only. What is the derivatives of this? 2. So now you don't have to differentiate next. Why? Because 2 derivatives is again 0. So I am stopping here only. Am I clear? Actually this become what? Actually the using the formula, it become like this, n minus 1, then it is already plus 2 plus 2. So you are getting n plus 1 only. So better remember in this way, the suffix of the y will decrease 1 by 1 u, and the suffix of the suffix means derivatives, order of the derivatives, and the suffix of the v will increase. So here also you have to apply u into v, yes or no? So this you have to assume as a u v, sorry, because it will different this as a v and this as a u. So listen carefully. Open the bracket. So x v un, so u n plus 1 plus nc1, decrease the y, so n only, and if I differentiate x, it become 1. After that it becomes 0, so I am not writing. So a square minus m square is a constant term. So if I differentiate this, so it become yn. Here you don't have to apply u into v, because this is not the function. A square minus m square is a constant term. Any doubt up here? So look over. Now what I will do, I will take a common part in one part, okay, one side. Okay, so it is, can we write x square yn plus 2? Listen carefully. This can be written as a what? N only. nc1 is a n only. N yn plus 1 into 2x plus nc2 can be written as a n minus 1. Clear? Then 2 and then 2 into yn plus, if I open the bracket, it become yn plus 1 plus nyn plus a square minus m square yn is equals to 0. 2 to cancel. So listen carefully here. So you have to arrange in proper order. Okay. If you see this one, dear, this part, and this part. Here, the suffix of the y is same. Yes or no? So if we common x y to the power of n plus 1, x, because here y to the n plus 1 into x, it become what? 2n plus 1. Any doubt? Yeah, plus. If you see this part, this and this, here the suffix of the y are same. yn, yn, yn. So when I common this one, so it become, look over it, yn over here. Clear? If I open this one, it become n squared here minus n. Here plus n. Any doubt? Clear? And here you are getting plus a square minus m square. This is the suffix of the y. In this way, you have to equals to 0. So n cancel. So this is your nth order derivatives equation, because you are differentiating n plus n times the given differential equation. So you got n square plus a square minus m square yn is equals to 0. Any doubt? Clear? So look over. Again, this one also. So again, this part is here. This you have to assume as a v. This you have to assume as a u. So differentiating with n times with respect to x. So can we write in this way again? So this is a v, n times means n plus 2 plus nc1. This will, your suffix will decrease by 1. So y n plus 1 only. If we differentiate this one, it become minus 2x plus nc2 y n only, because n plus 1 again 1 decrease, and if we differentiate this one, it become minus 2. After that, it becomes 0. So I am stopping here only. So be careful, because there is a minus sign, so you must open the bracket. Again, here you have to assume this as a v, this as a u. So v, yes or no? V, if we differentiate n times, this is n plus 1. So what is the Leibniz theorem? So n c1, your suffix of y will decrease, that is n, and ddx of x is 1. Now you don't have to differentiate again, because after that v2 will become 0. So again, a is a constant term. You don't have to apply Leibniz theorem, you just differentiate only. Clear? So now listen carefully. So 1 minus x square, open the bracket, minus 2xn yn plus 1 plus, if I open the bracket here, minus 2. So when I solve this one, so it become n plus n minus 1 by 2 yn. So when I open this bracket, yn plus 1, and here minus n yn, using properties of the combination. So if you see, this is yn plus 1, yn plus 2 is 1 only. But if you see n plus 1, it is here also, it is here also. That means, can we say, if we common minus xyn plus 1, you find 2n over here, 2n. Here minus you have common plus 1. Clear? Similarly, suppose plus, if you solve yn part, so when I open the bracket, it become minus n square, minus minus plus n. Here is a minus n, here plus a square. Check it. Am I clear? I'm just what? Solving, putting one similar here terms in the one part. Clear? So n cancel. So you are getting. So in this way, we'll differentiate what? Differential equation. N times, we'll differentiate n times of the differential equation. Yn is equals to 0. This is the final answer of that part. Any doubt? So look over here. Here they have already given the differential equation, and now I am finding the n times differential. What we see here, if it is 2 dear, you are finding n plus 2. Yes or no? Because we are differentiating n times. So listen carefully. Okay. Main part, in your exam, 5 marks question will come in this way, where y is equals to what is given? A cos log x is given, and you have to prove this one. Now here we'll apply the class 12 concept. You know, I have taught you in the class 12 that whenever you are solving y2, you don't have to see the answer. You know the equation one. The equation of the y2, the difference, because look over, because here if we see, you have to prove this equation where it contains n plus 2. So just now we have proved, we have solved some questions where we are finding n plus 2. That means first 2 times you have to differentiate by yourself. That means first of all, you have to frame the differential equation of how many order? Second order. Am I clear? Why I'm solving? Because look over it, this part. Here look over. So second order differential equation. This is the second order differential equation. Then you have differentiating n times. To get n plus 2, so you need first second order differential equation, and make sure that the second order differential equation should contain only what? X, y, you know, x, y, y1, y2 and constant term only. Clear? These 5 things only. So look over. So here, that means this type of equation, whenever it comes, so here you have to see the highest suffix n plus 2. You have to find first second order differential equation, which contain only what? X, y, y1, y2 and constant term. That's it. They should not contain any cos log x, e to x, any other function. Clear? So first part is a class 12 concept. So look, what is a y1? Y is a cos what? Log x. What is a y1? Y1 is a is constant term. Ddx of cos theta is minus sine theta. Again applying chain rule of ddx of log x 1 by x. You know, whenever there is denominator, you have to cross multiply it. Michael, you know this thing. I've taught you during your class 12 also this part. Whenever there is a denominator, cross multiply it. Again differentiate one more time because I need a double order derivative. So x, this is a y2, applying u into v, plus y1 ddx of x is 1 equals to minus a. ddx of sine x is cos x. Again applying chain rule in the log x, 1 by x. So cross multiply it. So you are getting x square y2 plus xy1 is equals to minus, isn't it? Can we write this part as a y? Check it. Clear? So that means this x cross multiply x square. So this is your second order derivatives plus y is equals to 0. Now tell me if you have any doubt. Now you know very well what we'll do. Now we'll differentiate how many times? N times. Am I clear? N times using Leibniz theorem. Well, any doubt why I'm differentiating these 2 times? No doubt? Okay. So look over. So that means you get this equation. Yes or no? Why I'm finding double order derivatives? Because you need n plus 2. So that's why. If it is n plus 1 only, I'll just differentiate one order derivative differential equation only. Clear? First order only. So now after that, you know that it is same like a previous question, differentiating n times of the differential equation. Clear? So differentiating what? N times using what? You must write Leibniz theorem. Okay? We get. So which is u, which is v? This is your v because it will differentiate fast, and this is your u. This is your v, this is your u. So look over. V u n plus 2 plus nc1 y suffix will decrease, that is n plus 1 only. If we differentiate x square, it becomes 2x. Yes or no? Because n minus 1, you have to differentiate v1 plus nc2 y, you just decrease this one. Actually it is n minus 2 plus 2 because there is already. So better don't go with this one, just decrease the y suffix, so n. And if we differentiate 2x here, it becomes 2. After that you don't have to do because it becomes 0. Plus again here x y1. So x as it is, y n plus 1 plus nc1, decrease the y suffix, that is y n only, decrease the y suffix by 1. If you differentiate x, it become 1. After that, you don't have to do because it becomes 0. And if you differentiate y, it become yn. Any doubt? Now, again, using same concept, yn plus 2 over here plus n yn plus 1 2x plus 2. Can we write this as a n minus 1 by 2 yn plus, if I open the bracket, it become yn plus 1 plus nc1 is n, yn plus yn is equals to 0. Now, same like our previous questions. So we'll write x square, we'll write the similar terms in one bracket, okay? So 2 to cancel. So if you see this and this here, so what is common? So common is here x y to the y suffix n plus 1. So you are getting 2n plus 1. Any doubt? So next, if we see the yn part here, yn part, clear? So here you are getting n square minus n. Am I clear? When you open bracket, here you are getting plus n, and here you are getting plus 1. So n cancel. Isn't it? You are getting the same answer. X square yn plus 2 plus 2 n plus 1 x yn plus 1 plus n square plus yn equals to 0. Proved. Clear? So last question, one more question, then one question. I'll just I'll just find out the second order derivative. After that, differential equation I've already taught you. Clear? So here also look over it. Here also you can easily identify. Look over here. What is n plus 2? That means, but here y is only given. So first you have to find out second order differential equation which should not contain x, y, which should contain only x, y, y1, y2 and constant term. Clear? So look over. So y is equals to what? Sine m sine inverse x. So what is a y1? Dx of sine x is cos x. Applying chain rule, m is a constant term, dx of sine inverse x is under root of 1 minus x square. So cross multiply it. As I have already told you, whenever you will do differentiate, after every step, if there is a denominator, cross multiply it. Because we need a one line linear expression of the differential equation. Again, differentiate one more times. You have to apply u into v over here. So this u, if I differentiate y2 plus y1 as it is, ddx of root x is 1 by 2 root x. Applying chain rule over here, you are getting minus 2x. M is a constant term. ddx of cos x is minus sin x. Clear? And when I apply the chain rule inside the bracket, m is a constant term, ddx of sine inverse is 1 root of 1. Any doubt? This you have done in class, which class? 12. Class 12 you have done this part. So 1 minus x square as it is in the LCM part. So you are getting, or directly we'll do in this way, okay? I hope you learn. What is here? Under root of 1. If I multiply in this way, it become what? 1 minus x square, because under root will cancel. Minus xy1. Am I clear? Because when I cross multiply, this and this will multiply, will give you what? 1 minus x square. And when you multiply this one, this denominator and that part will cancel. So if you see here, dear, this m and m will give you m square, and isn't it from here to here, it is actually y. So this is the second order differential equation which only contain x, y1, y constant term and y2. This is very important, because this is actually, that's why in class 12, while I am teaching this type of question, I have told you that without seeing the proving part, you can prove this one. In class 12, you have to prove this one. This is the reason why I taught you in class 12. Clear? So look over. Now we have to differentiate what? This, how many times? This you have to differentiate n times using Leibniz theorem. Clear? So look over. So look over. So that means we have a this differential equation. So now I'll write what? Differentiating and at times n times with respect to x using Leibniz theorem. Clear? So again, this as a v, this as a u. So v u n. So if we differentiate n times, it become what? N plus 2 plus nc1, decrease the suffix of y by 1, so it is 1 only. If I differentiate this, it become minus 2x. Again, nc2, decrease the suffix by 1. If I differentiate this, it is minus 2 only. Now you don't have to differentiate because it becomes 0. Minus, again here, this has a v, this has a u, this has a v, this has a u. So v y n plus 1 plus nc1 y, decrease the this by n and ddx of y. Now you don't have to differentiate, is equals to, is this my, yeah, is equals to minus m square y, isn't it? So minus m square is a constant term, y differentiate n times y n. Any doubt? Now it's all about arrangement. Clear? So look, so this 1 minus x square. So what I am saying over here is, in our answer part, n plus 2 is only in the LHS part, all everything is in RHS, so I'm keeping in this way only. Check it. Clear? So I'm just keeping this only in LHS, everything in over, because if this is minus here, if you put into that side, it become positive. Okay, so that means, can we write nc1 as a n only? So I'm directly writing 2nx y to the power of n plus 1 plus 2, this is 2, and nc2 is what? N minus 1 by 2 yn. This negative, if we put into that whole bracket part into that side, it become positive. So plus xyn plus 1 plus nyn minus m square yn. Am I clear? Equal this one. Just I am keeping this in one side. Everything I am putting over there and also expanding nc1, nc2, nc1 and opening the bracket as well. Clear? So if you notice this one, 2 to cancel, this part is common. So 2n plus 1, because if we common x y to the power, take our common as a x y n plus 1, you are getting 2n plus 1. So if you see yn part another in bracket, if you write the yn part here, so when I open the bracket, it become n square minus n, this become plus n, and this become minus m square is equals to 0. So n cancel, so n square minus m square over here. So proved. Any doubt now? No, sorry, this is not equals to 0, because we have our everything we have put over there. Proved. So this is how we'll apply Leibniz theorem in sum. So main part is identify. Remember that you cannot directly find this directly from here to here. No, because Leibniz theorem is to find out nth order derivatives only. To find out the nth order derivative. But here it is n plus 2. So that's the reason why first you have to find out the second order differential equation. So just this question is for your practice. So here this is also same thing, n plus 2. First you have to find what? Second order differential equation, because it is n plus 2 dear, but it is this type of equation. So you can write in this way, cross multiply it first. Can we write in this way dear? Because what I have told you, whenever you need a second order differential equation, it should only contain x, y, y1 constant term, and it should be the linear expression. Whenever you'll find denominator, cross multiply it, because u into v is more easier than u by v formula. Clear? So when you differentiate this, what is the cases? This as a u, y differentiate means y1 plus y as it is, ddx of root x is 1 by 2 root x. Again applying chain rule, you are getting what? Minus 2x, and here 1 by under root. So when I cross multiply it, it become 1 minus x square y1 minus 2 to cancel. This will cancel, yes or no? So minus x y is equals to 1. Very simple now. Now you know how to differentiate. Clear? You have to do one more times. Why you have to do one more times, dear? Why you have to do one more times? Because here yn plus 2. You cannot apply n at times derivative. So again you have to differentiate one more time. So when you differentiate one more times, it become yx square. If we differentiate this one, it become y2 plus y1 as it is. When you differentiate this, it become minus 2x. Here apply chain rule. So x, when you differentiate this, it become y1 plus y. Differentiating x means 1 is equals to 0. So first you have to find out the second order derivatives equation. So I think this is a minus 2x minus x will become minus 3x y1. Am I clear? And minus y. So this is the second order differential equation. Now you know what to do. Differentiating n times using Leibniz theorem, you'll find the equation. This is how you'll apply. Am I clear? So that means first in the previous classes we have done Leibniz theorem, how to prove the Leibniz theorem. We have applied the application of the how to apply the Leibniz theorem. Main part is that choosing u and v. You cannot choose randomly any function as a u and v. You have to choose v, which will differentiate fast, and it will give you 0. Clear? Clear?